Hello folks, welcome to Mr. Pi. Can you find the area of this part FEGH? Pause the video and try for yourself in 3, 2, 1. We have a square in which we have two quarter circles and two smaller quarter circles. We have side of the square to be 2 units, and this point and this point are the midpoints. Okay, so begin this question with joining AE, joining AE and EB. Okay, so let's join EB. We have joined EB. Okay, now notice that this circle right here has a radii of 2 units, so AE will also be equal to 2 units. Similarly, BE will also equal to 2 units. So we have base to be 2 units and all the sides are 2 units, so this is an equilateral triangle. So this angle right here will be equal to 60 degrees. Now what we will do is we will add, to find this area, we will add this sector right here and we will add the other sector from taking side AE. So AE and AB will give a sector, and similarly EB and AB will give a sector. So green area is equal to finding the area of this sector. So let's try to find it. So area of sector, let's assume it to be ABEF. Okay, ABEF has an area of, so this angle right is equal to 60 degrees. So we know that the formula is 1 by 2 r square theta, that is 2 square into theta is equal to pi by 3 because it is 60 degrees. So we get 2 pi by 3. We must add this twice because this sector right here will give this portion, but to get this portion right here we will add other sector, so we'll multiply it by it 2, so we get 4 pi by 3. But notice that when we add two sectors, this equilateral triangle comes twice, so we must subtract it. So area of equilateral triangle we must subtract it, so we'll subtract 4 pi by 3, we'll subtract negative of area of equilateral triangle equals to root 3 by 4 into a square, which is a square of the side. So square is equal to 2 square will be 4, so we will get 4 pi by 3 minus root 3. Okay, now what you have to notice is that in this question, this right here, this sector, you can see it as AEH and BGH. This is coming twice. To find it, we must just draw a simple construction from point A to G, point A to G, and now joining point G and B. Okay, joining point G and B, and assuming this angle to be beta. Okay, and this angle, just will draw a perpendicular line from the other point to the point line BG, perpendicular. Okay, so this side is equal to beta. So, and this is the bisector, so this will be theta, another angle will also be theta because this is an isosceles triangle and the median of it will be a bisector. So now from this triangle A, let's assume this point to be M. From A and B we'll find tan theta. So tan theta is equal to, sorry, we'll use sin theta. Sin theta is equal to perpendicular by, sorry, the perpendicular by hypotenuse. Okay, so perpendicular right here is equal to mg, and for this small circle the radius is 1, so mg will be half of 1, which will be 1 by 2, and the hypotenuse is equal to 1, sorry, mg, and we have ag is right here is equal to 2 units, so into 2, so we'll get sin theta to be 4. Again understand that we have triangle AMG here, perpendicular equals to mg, which will be half of the radius equal to 1, that is 1 by 2, and for the hypotenuse this is radius of the bigger circle, so it will be 2, so we have 1 by 4. Now for cos theta we will use cos theta is equal to root over 1 minus sin square theta, 1 minus 1 by 4, that is equal to 1 by 16, that is equal to 0 16 minus 1 15, that is root 15 upon 4. So we now you'll find sin 2 theta we'll use in later part of the video. Okay, now okay, to find this area right here, that is BMG. Okay, this small portion here, right here, this small portion has an area of this sector minus area of triangle, this area of AGB. So area of AGB will be, as previously discussed, 1 by 2 into multiplication of two sides, that is AG into AB, that is 2 square, into sin theta, sorry, sine 2 theta. So we find the total area, but you have to subtract the area of this triangle. So the area of this triangle will be negative of 1 by 2. Sorry, we have find the area of this sector. So this is the area of the triangle. To find the area of the sector, we must use 1 by 2 square sine 2 theta. This is the sector. So 1 by 2 r square sine theta, sine 2 theta. Yeah, we are correct. Now we have to subtract the area of this rectangle, which is 1 minus 1 by 2, the sides multiplied into the angle between them, sine 2 theta. So I found the mistake. So the mistake is that we have to use the angle, not the sine of the angle. So the area of this will be 1 by 2 square sine 2 theta. So we'll get 4 theta negative of 1 by 2 square, that is 2 sine 2 theta. So sine 2 theta can be written as 2 sine theta cos theta. So 4 theta minus of 2 to 4 sine theta is 1 by 4, and cos theta is root 15 by 4. So we'll get here 4 theta is equal to root 15 by 4, 4 theta minus root 15 by 4, which is the required area of this smaller portion, right here. But we know that this smaller portion is twice, the other one is also here, so we should multiply it by 2 and subtract it from the main question, which is here. Okay, we'll subtract it at later. Let's subtract it now. So 4 pi by 3 minus root 3 minus 2 multiplied, that is 4 is 8 theta minus root 15 by 2. Now what we will do is we will find the area of this sector HGB. So for it we will use the previous formula, it is and we'll subtract it and again multiply by 2 into 2 into 1 by 2 r square, it is radius 1 squared into angle between them, it is beta. So we'll get negative of beta. So 4 pi by 3 minus root 3 minus 8 theta minus root 15 by 2 minus of beta. And here what we have to do is that we have to find the value of beta in terms of theta. So here focus is that this is beta, this is theta, so the addition of beta and theta will be 90 degrees. So beta can be written as beta equals to pi by 2 minus theta. So we can write it this area as 4 pi by 3 minus root 3 minus 8 theta minus 15 by 2 negative of pi by 2 plus theta. So we'll get 4 pi minus 3 minus root 3 minus 8 theta plus theta, is minus 7 theta, but theta can be written as sine inverse root 15 by 4, sorry, sine inverse 1 by 4, sine inverse 1 by 4, and finally minus 15 root 15 by 2, which is the required area of the question. So the final answer is 4 pi by 3 minus 7 sine inverse 1 by 4 minus 15 root 15 by 2 and minus root 3, which is the area of the required Batman. Thank you. We forgot to write this minus pi by 2 from this right here, and this is the total answer. Thank you.